Module 3, Database Design. Overview of database design. Database design is the process of creating a well-structured and efficient database schema to store and manage data. It involves defining the structure, organization, and relationships of the data, as well as designing the database schema and selecting appropriate database management systems, DBMS, and technologies to implement the database. The process of database design generally includes the following steps. 1. Requirement analysis. This step involves understanding the data requirements of the system or application that the database will support. It includes identifying the types of data, their relationships, and the operations that will be performed on the data. 2. Conceptual design. In this step, a conceptual data model is created, which represents the high-level, abstract view of the data and its relationships. The conceptual data model, often created using techniques such as entity relationship, modeling, or unified modeling language, UML, provides a visual representation of the data and its relationships without being tied to any specific implementation technology. 3. Logical design. Once the conceptual data model is finalized, the next step is to create a logical data model. The logical data model translates the conceptual data model into a more detailed representation using a specific data model, such as a relational model, hierarchical model, network model, or object-oriented model. The logical data model includes defining tables, columns, primary and foreign keys, relationships, and constraints. In conclusion, database design is a critical step in creating efficient and well-structured databases that can effectively store and manage data. It involves understanding the data requirements, creating conceptual and logical data models, translating them into a physical database schema, implementing the database, testing and optimizing it, and maintaining it over time. Proper database design is crucial for ensuring data integrity, performance, and scalability in a database system. Database Management Systems. Database Management System, DBMS, is a software application that is used to create, manage, and interact with databases. It provides an interface between users or applications and the underlying database, allowing for efficient storage, retrieval, and manipulation of data. There are various types of DBMS that are commonly used in the industry, including 1. Relational DBMS. Relational DBMS is based on the relational data model, which organizes data into tables with rows and columns, where each table represents a relationship between entities. Examples of relational DBMS include Oracle Database, MySQL, Microsoft SQL Server, and PostgreSQL. 2. NoSQL DBMS. NoSQL, not only SQL, DBMS is a type of DBMS that is used for handling unstructured or semi-structured data, such as JSON, XML, or key-value pairs. NoSQL databases are designed to scale horizontally and provide high performance for handling large amounts of data. Examples of NoSQL DBMS include MongoDB, Cassandra, Couchbase, and Amazon DynamoDB. 3. Columnar DBMS. Columnar DBMS stores data in columns rather than rows, which allows for efficient storage and retrieval of columnar data. This type of DBMS is particularly useful for analytical workloads and data warehousing. Examples of columnar DBMS include Google Bigtable, Amazon Redshift, and Apache HBase. Each type of DBMS has its own strengths and weaknesses, and the choice of DBMS depends on the specific requirements of the system, such as data volume, performance needs, scalability, data structure, and application use cases. Proper selection and configuration of a DBMS are crucial for efficient and effective management of databases in various applications and industries. Database Design Principles. Database design is a critical step in creating an efficient and effective database system. The following are some key principles of database design. 1. Data integrity. Ensuring data integrity is one of the fundamental principles of database design. This involves creating a database structure and rules that prevent the insertion of invalid or inconsistent data. Data integrity can be enforced through the use of data types, constraints, and validation rules at the database level. 2. Normalization. Normalization is the process of organizing data in a database to eliminate redundancy and inconsistency. This involves breaking down data into smaller, logically related tables to reduce duplication of data and ensure data consistency. Normalization helps to reduce data anomalies and improves data integrity. 3. Entity relationship, modeling. Modeling is a technique used to visually represent the relationships between entities in a database system. It helps in identifying the entities, attributes, and relationships between them, and provides a clear understanding of the data structure and relationships. 4. Data consistency. Ensuring data consistency is essential in a database system. Data consistency refers to the accuracy and reliability of data, ensuring that data is valid, accurate, and consistent across all tables and relationships in the database. By following these principles, a well-designed database system can be created that is efficient, scalable, secure, and capable of meeting the data requirements of the application or system it supports. Thanks for watching. For more information, like, comment, and subscribe our channel.